Happy Math.
Okay guys, today we'll be talking about curve sketching, which is basically the same as graphing a function. These are the 8 steps to curve sketching. And the first step is domain, and that's basically which x values can you plug into the function. And in order to find the domain, you just find where x will make y undefined and not include that in the domain. One thing to know is that polynomials and sine and cosine functions usually contain all real numbers. Okay, the next step is finding the intercepts of the function. This is just basically algebra, setting x and y to 0 and finding where the function touches x and y axis. Okay, the next step is finding the symmetry of a function. There are usually 2 types of symmetry, one at the y-axis and one at the origin. Even functions usually are at the y-axis, and odd functions are usually at the origin. If you don't know if it's even or odd, you can use the expressions above to determine which symmetry it has. Next, you find the asymptotes of the function. Asymptotes are basically like limits. It approaches a value, and so in order to find a vertical one, you set the denominator to 0. For horizontal, you follow the rules here, and in special cases you have a slant asymptote. Sometimes you can actually cross an asymptote, and that's usually the horizontal one. Okay, now the calculus starts. First, you find the derivative of f of x, then find the critical numbers by setting the derivative function to 0 or undefined. Then you plug in values to see where the derivative is positive or negative. Where the derivative is positive, f of x is increasing. Where the derivative is negative, f of x is decreasing. Now we can use the information to find the relative extrema. Local maxima will occur at critical points where the derivative comes from positive to negative. Local maxima will occur at critical points where the derivative changes from negative to positive. Now, in order to find concavity and points of inflection, we use the second derivative of f of x. We find the critical numbers of the second derivative function by setting it equal to 0 or undefined, then plugging it in where it's positive, f of x is concave up, and where the second derivative function is negative. In addition, there are points of inflection where the concavity changes. So where the second derivative function changes signs from positive to negative or negative to positive, there are points of inflections. Finally, we can use all this information that we've gathered to create a graph. Start by sketching out the points, and in the end you'll get a general shape. Now Adam will show you 2 example problems.